All right, we're continuing with systems of equations, but this time we've moved past linear and we're going to go to different kinds of intersections. We're going to see several kinds in this lesson, but the first we're going to take a look at is what happens if a line intersects with a parabola. So if you graph them, you could obviously see all the possible solutions. You may have no solution, they don't hit at all. One solution if they just catch right on the corner there, or two possible solutions if the line crosses the parabola. So we're going to use all of the methods that we have used previously, particularly substitution or the elimination, what the book calls addition. And we're going to use those tools to try to help us solve them. So let's go ahead and take a look here. Now, this is already solved for substitution, but because of the x squared, I'm going to save that to be the second equation. Let's start with this here, where what I'm going to do is I'm going to solve this for x. Just send the y to the other side. I get this. Now, if this is what x is equal to in this universe, we're going to drop this into the parabola. And if we come up with some real values, then that means that this line must be true inside of the parabola at this location. In other words, it must be where they intersect. So we're going to drop that in for x. Now remember, you sub it in for x, it goes into parentheses. And so what we're really doing here is we're foiling out y minus 1 times itself. Y minus 1 times another y minus 1. Now if you know the shortcut, because you multiply something like by itself, you get this. Now we're going to combine a little bit, so I've got a 1 here, so this gets me 2. Now this whole thing equals y. So y equals all of this. Now if we want to try to solve for y, the possible values for y, well, we need one of the rooms to be equal to 0. So we're going to send this y over to the other side. He's coming over here. If he switches rooms, he's now negative. So I get y squared minus 3y plus 2 equals 0. So this factors. So we can factor this down. We get y minus 2, y minus 1. And so if those equal 0, the zero product property says either one of these might be the reason it equals 0. So we get two values. Y is 2 and y is 1. Now, because we had a square root, or a square, we have factored this down. It is possible that we originally only had a line. So it's possible when we had a square that we're creating an extraneous solution, one that isn't really true. So it's possible that, think of it like you're taking the square root, you get the plus or minus. It's possible that anytime we're dealing with the plus or minus, perhaps one of them isn't the case. So we could double check this by plugging these back in to the original equations, and we get x is 1 and x equals 0. So these are two valid solutions. This is true. So we could, again, double check them if we wanted, but it is going to turn out to be true, and our graph looks something like this, where this line has hit the parabola in these two locations. Okay, let's try another one here. We could do anything we want. We could substitute if we'd like. We could do elimination. Elimination would be pretty easy. Yeah, we're going to get the same boat no matter what we do. So let's do elimination. I'm going to run a negative through here. So I'm going to get negative 3x plus y equals 2. Now this is 2x squared and 3x, so they don't line up. So what we're going to get is 2x squared minus 3x, and then this will get us equals 0. Okay, so, I'm sorry. I could swing him over and it equals 0. I'm going to bring this 2 over to the other side. Okay, so we're going to try to factor this. All right, sorry, someone came in. So I had to pause it for a second. So we would add this up. This negative 2 would actually come down here, but I just went ahead and swung it to the other side. So we run a negative 1 through that first one, creates this equation. Now we put them together, and the 2x squared minus 3x don't join up, so we create this, and I've moved the 2 to the other side. Okay, so we can factor that. We're going to get 2x. Now this is the AC method if you're not real good with your factoring, but you can also do guess and check. I'm just going to go ahead and do this one in my head. So I'm trying to factor this down. Do I have it right? No, I don't. Is that right? No. Hold on, I got that wrong. Yeah, here we go. Okay. So solving this, I'm going to get x is negative 1/2 and x is 2. Now I'm going to put this back into the linear equation here to make sure I don't mess anything up. So I get negative 3/2, send that to the other side. It's going to be so y is going to be 1/2 for that one. So one solution is going to be negative 1/2, 1/2, and the other solution, putting 2 in there, 3 times 2 minus y equals negative 2. 6 minus y is negative 2. Okay, so y is 8. Okay, so here's our two solutions. You could again double check these, but they're going to turn out to be true. Okay, so that was a parabola and a line. How about a circle and a line? Well, if you see here, here's all our possibilities. Again, perhaps the line never touches the circle. Perhaps it hits in one spot, or perhaps it crosses in two different locations. So we're going to do the same ideas that we had here. We've got x squared plus y squared is 5, and I've got this set up perfectly for substitution. So let's go ahead and put it in. And if we can find an answer, that means that this line must have been true inside of that circle at a certain point. Must be a solution. So if I substitute 3x minus 5 into y squared, we create this. We would FOIL that out, or if you know the shortcut, you're going to create this. Now, let's see what we've got. So just tidying some up, I've got x squared here, 9x squared gets me 10x squared. Now, if we want to solve that, what I would do here, you always take a GCF out. So I'm going to pull a 10 out of there, which creates this. Factor it down. Here are my two solutions. Now, putting those back into the original line, we get, put a 2 in there, you get a 1. Put a 1 in there, you get a negative 2. So here's our points. And if we double check those in the original equation, we're going to find that it is true. You graph it, you can instantly see the solutions. The line crosses through the circle in those two spots. Okay. Yeah, so this is pretty similar here. If I want to try to solve where this line crosses this circle, I could do it different ways, but I've got a nice substitution set up if I solve for x down here. So if x is 3y minus 10, if I put that into the other one and find a solution, that must be where it's true for both. So let's see what happens here. Okay, so I'm really foiling that out. I did that in my head. Hopefully you followed me there. I'm just combining the y squareds. Now I should have done this in one step here. I'm going to bring this 10 over to the other side. So this is 0 over here. It's going to make that 90. I'm going to do this in one step so I don't show. So I subtracted the 10. This was 90. Then I'm pulling out that GCF of a 10 over here. Okay, so I'm factoring this down. Let's see. Yeah. Creates this. So if I solve this here, my solution is going to be y is 3. Now we plug that back into the original equation here. X is then going to be negative 1. So at the point negative 1, 3, we got only one solution here. So this line must touch right at the edge of that circle, something like this. Now we could double check them, but I think we're going to be fine. It's going to be true in both, and there's our solution. All right, so things get much more complicated. We're going to take a look at a circle and an ellipse. Now, here's all the possibilities. If you think through the reasoning of this, all the way up from 0 solutions, they never touch, all the way to 4. So perhaps the ellipse and the circle could cross in 4 different locations all at the same time. So let's go ahead. We're going to see some different strategies here. It's still going to be elimination, the addition, whichever way you want to think of this. How did they do? Did they run? Yeah, they ran a negative 3 through this top one. So what we're going to do here is create negative 3x squared and 3x squared. And we combine those, it'll drop out. So We ran the -3 through here. So here's the original equations. Just now this was a -3 run through the top, which we've seen is perfectly legal as long as you run it all the way through. Now when we do this, we turn this into a big addition problem. The 3x squareds are going to drop out. 22y squared is going to equal 22. Well, y squared is going to be 1. So look what happens. Y is then going to be the square root of 1, so it's plus or minus 1. So this is why we're going to have the possibility for multiple answers here. We're going to plug the 1 and the -1 back into the other equation. Solve this and look what happens. We get plus or minus 5. So here's what we found. The x's could be 5 or -5. The y's could be 1 or -1. And so what we've got here is 5 and 1 and -5 and 1, 5 and -1, -5 and -1. So if you see the picture, and this is literally what happens, this ellipse and this circle intersect at 4 different spots. All right, let's try one more here. If you see, I'm looking to turn this into an elimination problem, a big addition problem, but what I'm going to do, I'm going to run a -1 through that bottom equation. So now I'm going to have 4x squared plus y squared equals 13. I'm going to get -x squared y squared equals -10. So I combine these, I get 3x squared equals 3, x squared is 1, x is plus or minus 1. So if I square root that, I'm going to get plus or minus 1. So let's now take these and plug them back into the original. It shouldn't matter which one. So let's just do, I'm going to do 1 squared plus y squared equals 10. That's just going to be 1, so y squared is going to be 9, so y is plus or minus 3. So here's what I've got so far. I've got 1 and 3, 1 and -3, -1, and 3. Actually, it's going to be the same. Let me plug in the -1. It's going to give me the same thing. So that's still 1. So y squared is still going to be 9. Okay, so here are the different combinations. We have plus or minus 1 and plus or minus 3. So it could be 1 and 3. Could be 1 and -3. Could be -1 and 3. Could be -1 and -3. And there are our 4 possible solutions. So the ellipse and the circle must intersect at 4 different spots. Okay, I hope that makes some sense. We've got those 4 solutions here. We're doing the same principles that we saw before. We just have to be careful because it's possible that we have up to 4 solutions if you were doing an ellipse and a circle. So, all right, give that a shot. I hope that makes some sense.